Hello again. In this video I'm going to show you how to design the reinforcement for pile cap, which is looking like this, and there is force acting on top of it. It is 2500 kilonewton, and because of that there are two reaction force, RA reaction force at A and reaction force at B, which will be 1250 kilonewton and 1250 kilonewton. So why I have assumed the height is 1400 millimeter. C says concrete cover, which is I have assumed 100 millimeter. X is the distance from this point to this point. It is I have assumed 2700 millimeter. X1 is 100 millimeter, and X2 is the pile width is considered to be 700 millimeter, and AB is the distance from this point over here to this point over here, center to center distance, center of this pile to the center of this pile, and that will be 1800 millimeter. And CD as the distance from this point to this point. This is all height minus the concrete cover, so it will be 1300 millimeter. Now AD is the distance over here, which will be the distance AB, which is from here to here, divided by 2. That will be 900 millimeters square. This way, since we know the height and the breadth, the height and the base of this base and the perpendicular of this triangle over here, right angle triangle, we can calculate the angle. So angle will be tan inverse CD as perpendicular and divided by base, and this will give us the angle of 55.305 degree. And now with the help of the angle, we could get the force per stud, which will be FC is this one, FC this line over here. This is calculated as follow. This is assumed like this is just done like sine theta equals to perpendicular divided by hypotenuse, and then this is how hypotenuse will be equals to like looking like this, and this will give us 1520 kilonewton. And again we can calculate the force acting on this line over here. That is calculated cot theta is equals to P by B, so P equals to the cot theta P, so that is reaction force times this, and this will give us 865.38 kilonewton. So this is the tension force. So going over here, that means this force should be equivalent to the tension reinforcement. So FT equals to area of steel times the capacity, yield capacity of the reinforcement, which is again there is some safety factor. This is FYK, the real capacity, which is 500 Newton per millimeter square divided by 1.15 if you want to do it according to Euro code, and otherwise there could be different value. And after having that, we get the area of required area of steel is 1990 millimeters square. We have assumed we have applied 5T25, which is going 5 of them like this. That way we can see the provided area is 5 times pi r square, which gives us 2454 millimeter, and it is the value is bigger than the required one, so that satisfies the required reinforcement in that area. And when we check the utilization, this is AST divided by area provided, and it gives us 81.095 percentage. And if we do the same thing with the help of beam theory, how it would look like, we have Q as 2500 kilonewton, and bending moment with the help of that force can be achieved, and it is 1125 kilonewton meter. Kilonewton meter. D is total height minus concrete cover minus diameter of reinforcement divided by 2, so that would be 1280 88 millimeters square. U is mu is looking like bending moment divided by BD square times FCD. So we have all the values, then we get 0.04. This should be less than 0.354. This is just to make sure that yielding happens on tension reinforcement, and after that we just calculate B value like this, and it gives us further we calculate the lever arm, and after having the lever arm we can assume of having this bending moment at the concrete compression part, and that way we can say area of steel times FYD times the lever arm would be equals to the bending moment, and this will give us area required, and this is 2052 millimeters square, and this is minimum required condition, and the area required for our design will be maximum out of these three, and this is looking like this should be the maximum area among these three. So then we will have the area required is 2702 millimeters square, and I have assumed initially in previous section we had when we applied this truss tension reinforcement check with this truss design method, then we had 5 T25 millimeter, but in our case if I put 5 T25 then utilization ratio goes more than 100%, which is definitely not possible. So then I just put 6, then it gives the good result. If I put 5, then it shows over here recheck, because now the area applied is less than area required, so we have to increase this here 6. And further we also have to do punching check and other check. In this video I will not go through that. In this video I'm just trying to show how to calculate the reinforcement, tension reinforcement here with two different methods. Thank you very much.